We're once again delighted to have Koji Oyama from Xcelux Design, who has some real-world experience and some valuable tips for media over IP network design. So take it away, Koji.
Thank you, Wes. Hi, everyone. Good afternoon. Are you enjoying the IBC show in person for the first time in 3 years? Yeah, great. Today, I'd like to introduce some tips for the media over IP network design. I hope some of my topics help you to develop your ST2110 based facility. This slide shows you today's agenda. First of all, I would like to introduce myself. My name is Koji Oyama from Xcelux Design Japan. I've been working as a technical consultant, evangelist of new technologies, and I'm also still one of the software and hardware engineers. Recently, one of the areas I focus on is to train MoIP engineers in order to let them expert engineers. So this slide shows you today's goal of my presentation. The target audience is the beginners and the newcomers of MoIP areas. One is broadcasting engineers who are not familiar with IP network. The other is IT network engineers who want to study MoIP. In addition, I believe it's also useful for some managers and leaders of development projects of MoIP facilities. This is because I've heard that there are some cases that the project management team underestimate time and human resources. And this is the objective of my long-term mission. The goal is to deploy enough MoIP expert engineers in the world. To achieve that, I believe we need more networking and education. One of the trial is to make Slack channel to exchange the information about MoIP network design. As you know, in the future, we won't need such MoIP network engineers because SDN controllers can configure all of the network switches in near future. But if you don't know fundamental network technologies, you never analyze any issues when your system doesn't work as expected. This is our reality at this moment. MoIP users use the IP protocol to transfer video, audio, and metadata by using Multicast, as you know. In general, IP version 4 Multicast is utilized. And in addition, we normally use IGMP version 3. But there are still equipment which support only IGMP version 2. In such case, we need to select network switches which supports SSM mapping. Sender is just to transfer data to Multicast groups. Receiver is to receive the data when it wants by joining the IGMP group. Multicast group addresses. And this diagram is in the JTNM guideline. I recommend you read it later. The point is that media networks are composed of amber and blue redundant network. Media network and the control network are separated logically or physically. And we generally use first octet number of 232 for Multicast streams. And this is an example of workflow for MoIP network design. So first, we count the ports and the sessions to select network switches. After that, we are refining the design and verify it. The point is that we need to design not only physically, but also logically. It is completely different from SDI-based design flow. So we need to design logically. And it takes longer time than we thought. And this slide is some tips of design and verification workflow. The process is, I believe, becoming as similar as software development. So, but checking physical cabling is still the basic when we need to check first. Second is you better to estimate more time for design and verification of the network. We usually underestimate it because we don't have a lot of experience regarding such technology at this moment. And similar to software design, we better to design bottom-up with agile design methods. And I recommend you to accumulate. You can accumulate know-hows and tools when you check the specific functionality at the verification phase. So larger and more complex the design becomes, more debugging time might be necessary at the design and the verification phase, so that you can build full or semi-automatic testing in the near future by combination such tools. Maybe you need them. This is an example of MoIP network. It has cameras, video and audio switchers, intercommunication equipment, recorders and the playout equipment, and grandmasters, and the network switches. PTP is distributing to each media nodes. It has redundant, duplicated network, amber and blue for media. Also, it has control network. Each controller ports are connected to network switches. The control network has redundancy as well. But in reality, we seldom see the equipment which has two control ports at this moment. So if the switches or equipment go into the trouble, we need to reconnect the control port to the other switch at this moment. And when you configure network switches, you specify adequate commands to implement the detailed network design. Unfortunately, the command differ depending on the switch vendors at this moment. And depending on the network OSs. So it's so you need to run the different languages. So I usually use 4 switches for one specific project. So I run the four different languages for the switches. And sometimes specification of the same command is slightly different. So you need to take care of that. And as I explained, explained the previous presentation at the NAB in April, These network protocols are what I believe you have to study. VLAN, VRF, multicasting, PIM, PIM, IGMP, OSPF, LAG, LAG, LACP, VRRP. So please check how many keywords you are already familiar with now. You know all of the keywords? Or so who had a zero? No, okay, yeah. Maybe you know, or so you have heard of the VLAN. And so today I don't explain in detail about each technology, but so please watch my previous presentation, a YouTube video, or Google it with the keywords. You can easily find it online, and it must be better explanation than mine. So VLAN is virtual local area network, which can integrate multiple L2 network virtually into one switch. So multiple, so separated L2 network into the one switch. This is one of the virtual technology, VLAN. And the second one is a VRF. VRF is virtual routing and forwarding, which can integrate multiple L3 routers into one switch virtually. So similar VLAN, VLAN is for the L2 layer and layer 2, but the VRF is for layer 3, so IP and as for the routing. So you can integrate the multiple L3 network into one switches. So one switch has a multiple VRF. And the multicast routing, multicast is one-to-many transmitting technology. So as you heard of that keyword, you use PIM, PIM, and IGMP protocol for it. And PIM is a protocol independent multicast. We normally use PIM SSM with IGMP version 3. And it's used for the media plane. There are 4 variants, but recently we use only PIM SSM. But as I mentioned, there still are equipment which supports only IGMP version 2. Such case we use the PIM SM. But to integrate the PIM-SM and the PIM-SSM network with the functionality of the SSM mapping. But some not only not all of the switches has a SSM mapping functionality. So then you have to select the switches which has SSM mapping. Maybe such switches are more expensive than the normal one. So I recommend you the integrate and select the equipment supports only the IGMP version 3. And IGMP is used when receiver want to get data or finish to get it. Maybe you can find which is helpful to understand the online So it has a great diagram, such as like this one. Then it helped you understand easier. And the OSPF is one of the routing protocol which can make routing table for each VRF router automatically. So you don't have to configure the each router by manually if you use OSPF. And LAG, RAG, LSCP is used for the redundancy of control plane. And VRRP is virtual router redundancy protocol when you need multiple default gateway. And it also used for the control plane. This slide is tips for verification. So I recommend you prepare such debugging tools at the verification phase. So prepare debugging port and useful, powerful PC to capture IP packets in real time. You better to know how to use Wireshark and PTP track found. These tools are very, very useful. So I want to thank you to the development team of these tools. So I always use them. And in addition, you better to learn Python or other software programming language to make verification process automatic. You often check with ping command to the availability of the media nodes manually, maybe but if you use Python or such kind of program language, you can check the availability automatically. So yeah, I know my friend who is broadcasting engineer and who don't like such kind of the software programming language. But you maybe in the near future you have to learn and study the software language if you get a job. And this slide shows the pitfalls you may face on based on the unpredicted issues of my experience so far. One issue is that the bandwidth overflow when switching multicast streams dynamically within one cable at the high load situation. It caused by short time between IGMP leave and join. So when you switch streams. And another is that the intended network path could be routed by OSPF in the event of a network switch failure. So bandwidth overflow is caused by timing of IGMP leave for the current stream and IGMP join for the next stream. It takes a little bit time to stop the multicast stream after receiver issues IGMP leave packet. If you issue IGMP join to switch the receiving stream, there is some overlap of the streams like this. So you need this is because you need to more bandwidth if you switch quickly. So and it may affect overflow of the network line, and it causes packet loss for other streams. So you need to take care about this situation. And to avoid the bandwidth overflow, there are three workarounds, I believe. One is that you need to design with sufficient time margin to switch the receiving multicast streams. Second is that you need to set the IGMP immediate relief option, if you have, and in order to shorten the time to stop the current multicast stream. Third is that you need to design with sufficient margin of bandwidth, so to avoid to happen that overflow. And this slide shows an example of unpredicted network path by OSPF. One is that so one of the router has once the router has troubled, OSPF updates each routing table dynamically, but sometimes it might find out unexpected paths at the design phase. It caused some trouble not to transmit multicast stream because there are unmatched case has happened between OSPF path and multicast path. To avoid that, you can configure some static path into the adequate routing table. So it means you never trust automatically routing by using the OSPF. So you need to take care of that. Okay. So conclusion. The lack of MoIP network engineer is getting a big issue. And you need to understand it takes some time to become an expert engineer. So this is my big challenge. Then they need to study a bunch of new technology about the network and the design flow. And then I believe we can help each other. Hope to see you again at the NV show, Las Vegas, next April. Thank you very much.
So do we have any questions for Koji-san?
How do we overcome that problem, that last slide, that challenge? How do we overcome that? Education, training, how do we overcome that? Because this is an industry challenge that we as an industry...
So you need to train somebody, just a step by step. Yeah, it takes a longer time than we thought. So to train, human, right?
So hopefully this is a part of the solution that you're participating in right here. So let's see how it goes. Okay. Thanks, Koji.
Yeah, thank you very much.